Hello there, my name is Dheeraj and in this video we'll understand what is machine learning, its practical applications and how it has been achieved. Before understanding what is machine learning, you must have to understand what was present before machine learning. The computers that we use generally, like the PCs or the laptops, are very good when we provide some task to it and it does it because it's been already pre-programmed. Tasks like storing, organizing or processing those huge bulks of data. Now this kind of pattern is very well suitable for companies like the social media or the e-commerce where the user would give you a task and that task is been pre-programmed. So as we can see here, the server provides them the task and the laptop just blindly follows it. And also we know that what kind of input the system would receive and what output should it must have to process. This is a traditional method. But what if we want our system to look into the data, to make decisions accordingly, or to make predictions accordingly in the way that human cannot actually hard code them? Now that's the point where machine learning comes to the rescue. In simpler terms, machine learning could be explained as the ability of a system to learn or to make decisions without actually programming them, but it takes decisions based on the data. Here, we are not teaching or coding anything because it's a system, but instead we are actually emphasizing on the word learning. Here, learning has a different meaning than what humans perceive it. Here, learning actually means that the system takes the values from the previous computation and then makes the decisions and results accordingly. Now this is achieved by using the training data and the test data, which I'll explain to you in a moment. Now let us take an example where ML is been actually applied. For instance, if we have a dog species like a German Shepherd or the Bulldog, our human mind could actually differentiate these both species based on the leg size, their height, weight, ear orientation, etc. But in system, it's a completely different thing. Here the system actually provides a classification based on the training data, and this is done by actually collecting the data, recording it and then labeling it with the correct values. This means that I must have to provide a data set which has all the features along with the label. Now this label holds a very special meaning, which I'll explain to you in a moment. Let us understand how it has been actually achieved. For the system, we provide values. Now these values are already been corrected with the label that we provide to it. So when the system processes those values, it neglects the label department and creates a model based on these values. And each and every time its computation gives a wrong label, it corrects itself with the correct label. Now this testing and training provides a model that helps us in predicting the species. Then after which, using the test data, we could predict the accuracy of the system. In simpler context, I mean to say is that during the training phase, we'll be providing an input sample to the system and that system would provide it to the learning methodology. Now this happens until the training data is been available. Once the training data has been completed and the learning method creates a model, the testing data is been provided directly into the learning methodology, which helps us in providing the accuracy of the model. Now, what do I mean by the word model? Model simply could be understood as a model artifact that helps us in training the data. It is the thing which actually predicts it. So, how could I represent the model in the machine learning? One methodology is by using decision trees. So as here in this example we can see that I have given some plant leaf to it. So it will understand whether it is actually a male or a female. If it is yes, is it an adult? So it comes under the 20% category and it provides these distinctions. Now that's the same way these neural networks also work. We'll provide the values to it and each neural network is connected to the next layer of the neural networks. So based on the value computed from here, it goes to any one of these. And after the value is being computed from here, it goes till here. So each and every level of computation provides us with a final value which is actually the label. The label I'm talking here. this label is been again provided to the system. Now this end system will verify its original label and then verify whether this computation process was correct or not. And if it isn't correct, it will correct its values and go to another model which gives it the same or the correct label. Now this training model is very useful in predicting the machine learning values and to give the most appropriate values. As these weights helps us in providing the precise values. So after providing the decision values and the precision values, we'll be going to the support vector machines. The support vector machines are nothing but a two-dimensional modeling system where the two values, like here I could mean the cross could be German Shepherd values and the dots could be the bulldog values, are being represented in a 2D planar. After the entire training data has been achieved, a clear distinction would be achieved, even though we could spot some values of the bulldog are this side and some values of German Shepherd are in here. It wouldn't matter because 100% accuracy cannot be achieved to each and everything. It's been achieved, and here whenever a new test data has been provided, if it lies in this region, it has been considered that the data is German Shepherd, and if it is here, it is considered it as a bulldog. Now this is the same figure when more and more test values have been provided. So then the system would actually take the vectors and create the path where most of the bulldog and most of the German Shepherd values are being clearly distinguished. So now whenever I speak about machine learning, most of the people would actually connect it to the AI. But for your amusement, it is actually nearly connected to data mining. It's because both the machine learning and data mining actually relies on bulks of data and actually trying to find patterns to predict them. So, but AI on the other hand is basically making the system to go completely autonomous. So these are both completely different things. But AI is a sub-branch of the machine learning, but machine learning actually has its roots from the data mining, as they both consider data before they could actually process something and actually try to find patterns in order to do the prediction. Now it's time for the real life ML applications. I think so most of the iPhone users would have asked the Siri what's the weather like tomorrow. So this data, this 7-day forecast data is being achieved only with the help of machine learning. Machine learning also has its roots in our day-to-day usage, like the YouTube or Amazon recommendations. I know most of you have seen this recommended for you, or the users who have seen this also have seen this. Is basically with the help of machine learning. Along with that, object and face detection system, like we see doing when we take a photograph, or with the super camera apps, this face detection system is being seen. Also, the self-driving autonomous cars also use the machine learning to always correct themselves and to better enhance their model. And the most recent one is that the Facebook news feeds that we see in our app or in the website also relies on machine learning to find what is trending and to display it onto the user system. I hope that you have understood what is machine learning. Thank you.